Welcome to your Unit 1 test review for Math 030 Pre-Calc Clinic. These are all the topics that we'll be covering, and I'll break them down on each slide. And I'm not going to go super in depth on how to solve each type of problem. I'm just going to do basically like, here, you try this and then pause and then you'll check your work. If there's a certain topic that you're struggling with, I suggest that you look back at the individual lesson videos back on the playlist for that. So for this review, you should have out a blank sheet of paper, any notes that you've taken, because you can totally use those even on the test, I don't know, and then a pencil and a calculator to practice. Okay, our first topic is solving inequalities and then compound inequalities. So this one is just solving a simple inequality. This is going to be question 1 on your exam. So go ahead and pause, write this down, and solve it. Press play to check your solution. Here is the worked out steps. Remember, solving an inequality is just like solving an equation. The only difference is if you ever multiply or divide both sides by a negative number, you must flip the inequality. So because we divided by -4, we had to flip to a greater than sign, and we have x is greater than 2. Yes, there are different ways to solve this in a sense of like different orders that you can go in, but you should still end up with this answer. And if you're asked to write an interval notation, which you might be, this is the interval notation. We have an open parenthesis because we're only greater than 2, we're not equal to 2, and it's everything greater than 2, so it goes to infinity, which always has an open parenthesis. So either answer is acceptable, it just depends on how Alex is going to ask you to submit your answer. Okay, the next thing we're going to look at is compound inequalities. And just like a compound sentence has and, or but in it, a compound inequality doesn't have but it uses ands and ors. And basically it's just like two inequalities with an or an and we just kind of use logic to see if it works or not. So these are just examples. Let's pretend that these were already solved, and these are like our solutions here. So let's see if this provides us with a viable solution or if we have no solution. All right, this is an or. So can something be both greater than 1 or less than or equal to -3? If you're unsure why the answer is yes, draw a number line and put the two numbers on it that are in your solutions, and let's graph them. So we have x is greater than 1, just like that. And I believe in actually I'm doing this in a more high school way, sorry. The way that I did it in these videos is we put this here. But you can totally use that open circle too if you want. And then can something be also less than or equal to -3? Sure. There's an or there. So these don't overlap at all, but something can be either here or here. So this is totally a viable solution, and we can write this as our final solution set. If we wanted to write it in interval notation, we can use our graph here, and we can say, all right, here this interval is from -infinity all the way up and including -3. Then we put a union symbol for or, and then our next one goes from 1, not including 1, all the way to infinity. So this is how we can write this final solution set in interval notation. All right, our next example is just the same solution except with an and. So can something be both greater than 1 and also less than or equal to -3? No. Let's see why that is. Again, it's the exact same graph. And something cannot be both greater than 1 and less than or equal to -3. I'm using dots here. These are the same thing as what I had up here. All right, something cannot be both here and here at the same time. They don't overlap. That doesn't make any sense. So this answer actually has no solution because of the word and. And lastly, let's try this last example here, and then we'll go into a you try problem. Can something be both greater than 1 and also greater than 5? Sure. How about the number 6 or the number 100? A number like 3 wouldn't work though. So let's just do a quick graph. 1, 5. Can something be both greater than 1 and greater than 5? Well, their overlap area is here. So in order for this and to work, really everything has to be greater than 5 because it would automatically be greater than 1. So our final answer is actually just x is greater than 5, meaning to write an interval notation would be from 5 to infinity. And that's all compound inequalities are. They're just using ands and ors and a little bit of logic, which you can double check by just quickly sketching the number line graph. Okay, please try this one here. Solve both and see if the answer is viable or not. Write it in interval notation. Okay, when we solve, we have a is less than or equal to 4 and a is less than or equal to 7. Can something be both less than or equal to 4 and less than or equal to 7? Yes, so long as it is just less than or equal to 4. So our final answer in interval notation is from negative infinity to 4 inclusive. Our next topic is absolute value equations. These are questions 3 and 4 on your exam. And go ahead and solve this one here. Remember, we have a maximum of 2 solutions to an absolute value equation. So pause and solve. Our 2 solutions are 13 and negative 15. All right, the only time an absolute value equation does not work is if our absolute value ends up being equal to a negative, because an absolute value cannot equal a negative. So when we divide both sides here by negative 3, to get the absolute value by itself, our first step, we'll have the absolute value of 2a plus 3 equals negative 5. An absolute value, remember, is a number's distance from 0, and distance can't be negative. So in order to solve and you get your 2 equations to solve, your absolute value must be equal to 0 or a positive number. And in this case, it's not. So this actually has no solution. Go ahead and try this last one. Our 2 solutions are 1 and negative 4. I actually checked them by just plugging them back in to the original pink problem and checking them mentally real quick. I would definitely recommend doing that on your exam. You do have plenty of time to take the exam, so please double check all your work before submitting. Our next topic is factoring, a huge concept. So I know I linked a lot of Khan Academy videos for this, and then I think did like an overview on my own. Factoring quadratics can take many forms. The first thing you always want to look for with factoring is a GCF. And let's see if there's a GCF. Nope. So the next thing is we want to determine kind of like what kind of quadratic is it. It is a trinomial, right? 3 terms. So it has the quadratic term, the linear term, and the constant. And when a is 1, which it's not here, it's 3, but if a was 1, that's a pretty easy one to factor. When a is greater than 1, we can use either the box method or kind of just do it all in a non-box method, I guess the traditional method. So I'm going to do both methods for this real quick. The first thing we want to do, which is the same for both methods, is to multiply a times c. And a times c is negative 24. So we want 2 numbers that multiply to negative 24 that are going to add up to our b value. And our b value is negative 10. So add to negative 10. So let's think of what those 2 numbers are. Those 2 numbers are negative 12 and 2. And so what we can do is we can actually expand this into 4 terms. So our first term stays the same and our last term stays the same. So 3x squared stays the same and minus 8 stays the same. However, this middle term of negative 10x, what we're going to do with that middle term is write it as the sum of negative 12x and 2x, because that's how we got to negative 10. The order that you write those doesn't matter. So now we have a 4-termed polynomial, and we are going to factor it by grouping. 4 terms by grouping. So our first 2 terms and our second 2 terms. So our first 2 terms, the GCF there is 3x, so we can factor that out front. What's left? X minus 4. The GCF of the second 2 terms here, again, I want x minus 4 in the parentheses so you can kind of work backwards, but the GCF here is 2. It's going to be a plus 2 because this term's plus. So we'll bring out a plus 2, and yes, that leaves x minus 4 in the parentheses. Factoring by grouping, we take the stuff that's on the outside, 3x plus 2, and that forms one factor in the end as our answer. And then we take what's on the inside, x minus 4, and that's our second factor. So we have successfully factored this quadratic. Now factoring is just reverse multiplication, so if you multiplied this out through FOIL, or if you just think about it as just distributing, you will get back to this original quadratic. Let's do the box method real quick. The box method, the first step is the same. So I kind of have that at the top there. The first step is the same. Remember, we multiplied a times c and got negative 24. We multiplied a times c and got negative 24. And then so we need two numbers that multiplied to negative 24 that added to negative 10. There they are. And so the box method uses that same first step. Then we draw a box. And in the very similar way, we keep the first term the same and the last term the same. So the first term, 3x squared, and the last term, negative 8, go in the first and last parts of the box there. And then that middle term, negative 10x, we break that into the negative 12x and the 2x in a very similar way. So again, this is just a visually different way. It's the same thing, but we're just doing it in a more visually appealing way. Then we're going to take out the GCF of each column and of each row. So let's go down the column. The GCF here is x. So we'll take that out and write it up here. The GCF here is going to be negative 4. I'm going to take a negative because the first term's negative. So minus 4. Then going across the rows, the GCF here is 3x. And the GCF in the bottom row is just a 2, and it's a plus 2 because this is a positive term. The first term is positive. So these are our two final factors, 3x plus 2 and x minus 4. So the methods, will give us the same answer. The box method is literally just doing this traditional method in a box. All right, the next one is for you to try. Write that down, pause, and then check your work. Okay, you can check both methods here. I'm going to move on real quick, so if you need to look at this work, go ahead and pause. Okay, the next question that you're going to have on your test is to factor by grouping, which we just did. It's the method of factoring used when you have 4 terms. So in this case, we have 4 terms, and I'm going to separate it again into the 2 groups. So in our first group, GCF is 2x, and what's left? Y minus 14. The same thing should be left in the, sorry, I did that wrong. It should be y minus 7. Oops. See, if you make an error, you can always double check. So I was looking ahead, I'm like, y minus 14 is not going to work. All right, so we took out the 2x, and we're left with y minus 7. And then in our second 2, we can take out the plus 3, and we're left again with y minus 7. And then our stuff on the outside, 2x plus 3, and our stuff on the inside, y minus 7 is our final answer. Here is one for you to try. Okay, let's take a look at this problem. Let's go ahead and pause and try it on your own. Okay, this one we factored by grouping, and we actually got here. And then I didn't realize this when I wrote the problem, but this is a difference of squares, so this one can actually be factored further. You won't I don't believe you'll have that on your actual test, but if you did recognize this is a difference of squares, it can actually go one step further. So we factored by grouping. We saw that, hey, there's a difference of squares here, so this can go one step further. And lastly, we can solve by factoring, which really doesn't need its own section, but you factor first, and then you set each factor to 0. So solving means finding the x-intercepts or finding the zeros. So we already have these both equal to 0. Go ahead and pause, write these down, solve them by factoring, set each factor to 0. Okay, number 1 was also a quadratic trinomial, except in this case a is 1. So we don't need to go through the whole rigmarole of the box method or getting into 4 terms. This one's super easy. Two numbers that multiply to 15, right? Since a is 1. 1 times 15 is just 15. So two numbers that multiply to 15 that add to 8. Boom. That's it. All right, so we set both factors to 0 and solve, so we get -3 and -5 as our solutions. Plug them back in if you don't think it's right. So we'll get 9, minus 24 plus 15 is 0. That works. Same thing with -5. All right, for number 2, this is only a quadratic binomial. We saw that there was a GCF, 7a, factored. Then you cannot forget about this factor out front. It's the GCF. It's still a factor. So we set 7a to 0 and get one solution, 0, a minus 3 to 0, and we get 3 as our second solution. When you have a quadratic, you are going to have that many solutions. So you have 2 solutions max. Sometimes the 2 solutions will be the same number, but a majority of the time you'll have 2 distinct solutions to any quadratic that you solve. All right, the next way that we can solve a quadratic is by completing the square. And in this case, we can't factor it, right? There's not 2 numbers that multiply to -3 that add to -8. I can't solve this through factoring. You could solve it using the quadratic formula. If you'd like to check your work, totally do that. But you do have to show the steps of completing the square, so you can't just get around not completing the square. So as a quick recap, we'll go through how to complete the square. We want to create a perfect square trinomial. So what we're going to do is get the 2 terms with x by themselves. So we're going to add 3 to get it over to the other side and leave a little space. So we added 3 and I left a little space here. So what we're going to do is add the same number on both sides because that's what an equal sign means. What is that number? We take half of b. Half of -8 is -4. Then you square it. So you get 16. All right, so we took half of -8 and then we squared it. So we got 16. That's what we added to both sides. Now we have a perfect square trinomial here. 2 numbers that multiply to 16 that add to -8 are -4 and -4. So we can write this as x minus 4, or x minus 4 squared. That's why we do it. And on this side, we'll have 19. Now we need to solve. So in order to get x by itself, we have to take the square root of both sides to undo that squared. So we'll have x minus 4, because the square and the square root undo each other. We'll have plus or minus root 19. And then I'm going to add 4 to both sides to get x by itself. Now the square root of 19 cannot be broken down at all. So we'll have 4 plus or minus root 19. Now Alex likes you to write these as 2 separate answers because they technically are. So you're going to write them as 2 separate answers separated by a comma. So one of them is going to be 4 plus root 19, and the other is 4 minus root 19. All right, go ahead and write down this next problem. Make sure it's equal to 0. And we want to solve this also by completing the square. Go ahead, try it, pause the video, and then play to check your work. Okay, our 2 solutions are listed below. Okay, the one that is on your test is a rational equation for finding the intercepts. And again, a rational equation or function is just one that has x in the denominator as well. So these are 2 examples of rational functions. And we want to find the intercept. So to find the intercept, we set the opposite variable to 0. So let's first find the y-intercept in number 1. So to find the y-intercept, we're going to let x be 0. So to find the y-intercept, we let x be 0. So we're going to let y equals, we have 0 squared minus 1 in the numerator, and then 0 minus 4 in the denominator. So our y-intercept is positive 1/4. That one was pretty easy. To find the x-intercept, we're going to let y be 0. So this is a little weird. We're going to let 0 equal this big fraction. But if you think about it, when does a fraction equal 0? A fraction equals 0 when the numerator is 0. 0 divided by any number that's not 0 is 0. So essentially, we can kind of just not even think about the denominator, right? Because we only care about when the numerator is 0 for this to equal 0. So we're going to let 0 equal x squared minus 1. And then we'll solve. So we'll have 1 equals x squared. Take the square root of both sides. Plus or minus 1 is x. So our x-intercepts are -1 and 1. If you'd like to plug this into your calculator, you'd want to plug it in with parentheses and then hit divided by and then parentheses again, or you can just use the fraction button to make it a nice fraction. But if you use your calculator, you'll definitely see that your graph crosses the y-axis at 1/4, and it crosses the x-axis twice, here and here. You can also use Desmos online for a free graphing calculator if you don't have one, and you can use this to double check your work. All right, go ahead and try number 2 on your own, pause the video, and then play to check your solutions. All right, our y-intercept is -5, and our x-intercept is 5/3. All right, graphing lines is going to be just one problem on your test, and what you want to do is make sure that you get it into slope-intercept form first. Although there are a couple different ways to graph a line, I'll show you just the first one is to get it into the form y equals mx plus b, so we want to get y by itself by adding 4x to both sides. Then we can clearly see that this is our m, our slope, and this is our b. So b is our y-intercept. It's where we start graphing on the y-axis, so it's right here at 1. And then our slope is 4, which is 4/1. It's positive. That means from this original point, we're going to rise 4 and run 1 to the right for our slope. So we're going to go up 4 and over 1, and then you can do that again. Go up 4 and over 1. If you want to start at your original point, you can go down 4. Where's 4? 1, 2, 3, 4, and left 1 to continue that pattern. And then we'll create a line. And Alex, it's, automatically has the arrows on it. I think you just need to plot 2 points and it'll make a line, because 2 points make a line. There is an alternate way of doing this problem, which is you can just find the intercepts. So you could, set each opposite variable to 0, just like we did in the previous problem, and you would find that the y-intercept is 1 and the x-intercept is -0.25. It's probably a little harder to do for this specific example, just because -0.25 is harder to graph, but that is an alternate method to graphing. Okay, the next main topic is evaluating functions, and you'll have technically 2 problems that look like this, but one of them is 2 parts, so kind of like 3 instances of evaluating a function, and they look similar to this. So f of x is going to be rational, and then in a different problem, g of x will be a quadratic. So let's first focus on f. We want to plug in 2/x and evaluate f at 2/x. So what I'm going to do is plug in, everywhere there's an x, I'm going to plug in 2/x. Looks complicated, but it'll get a little simpler. So what we end up having is 12/x minus 1 in the numerator, and then we have, when we multiply 22/x. Remember, this is really 6/1, and this is really 11/1. So when we're multiplying, we don't multiply the 6 by the denominator. It's 6 times 2, and then 1 times x. So same thing in the denominator. That's why we'll just get 22/x minus 1. Now, plus 3. It's different down there. All right, plus 3. So what we want to do is simplify this, because we have a complex fraction, which means a fraction in a fraction, which is kind of gross. But the way we can get rid of this is multiply by the denominator, the least common denominator, which is just x. So we're going to multiply all 4 terms by x. So multiply all 4 terms by x. So let's do that in the numerator, and we'll also do that in the denominator. So in our numerator, when we multiply x by 12/x, the x's end up canceling. So we're left with just 12. Then when we multiply x by that minus 1, we're left with minus x. Then in the denominator, we're going to do the same thing and multiply through by x. So x times this term here, the x's will end up canceling, and we'll just be left with 22. And then x times that plus 3 will be plus 3x. So it's kind of a weird problem, but it is on your assessment, and that is how we simplify it. So that's more a test of complex fractions and just simplifying something rather than evaluating a function, honestly. So go ahead and try doing the same thing, but by plugging in 6 over x, so you get some more practice with this. Go ahead and pause and then play to check your work. Okay, there's our final answer here for this next one. It's very similar. And I did forget to mention the reason that we can multiply both top and bottom by x is because we're technically multiplying by x over x, which is just 1. And so as long as we're multiplying both the numerator and the denominator by the same thing, it's legal mathematically, and it's not going to change the value or the meaning of the problem at hand. So again, kind of a weird problem, but I do want to make sure you're prepared. Okay, let's take a look at g of x next. All right, let's next focus on g of x. We want to first find g of x minus 1. So in g of x, we actually have 2 spots, again, just like f of x, to plug in x minus 1. So when we do that, we just want to be really careful. So when we plug this in, we'll have 2, and then we'll have x minus 1, and then that gets squared, and then minus 5, and then x minus 1. There's a reason I'm giving you subtraction in both of these, and then a subtraction here. It's because it's tricky. So you just want to be careful when you're distributing this minus 5 or negative 5. All right, we also want to be careful when we square x minus 1. Remember what squaring x minus 1 means. It means x minus 1 times x minus 1. So we need to get 4 terms out when we distribute. So x times x times negative 1, negative 1 times x again, and then negative 1 times negative 1. Those don't cancel, be careful. It combines to this in the end. So that's what we end up getting when we square x minus 1. You need to make sure that you have those 4 terms that'll simplify down to 3 when you square this binomial. All right, with that being said, let's keep going here. So we'll have the 2, and then that x minus 1 squared, remember, became this. And then I'm going to distribute that minus 5 through. So we'll get minus 5x and then plus 5. Then when we distribute the 2 through, we'll have 2x squared minus 4x plus 2, and then those last 2 terms again. And then it's just a matter of combining like terms. So there's only 1 quadratic term, but then there are 2 linear terms that combine to negative 9x, and then 2 constants that'll combine to a plus 7. Now, it's very simple to, it's really easy to make errors in something like this, so I always recommend in every problem to please double check your work, whether that means at the end do the problem again or go through step by step and make sure everything's correct. All right, go ahead and write down the second one, pause, and then play to check your work. The final answer is boxed in yellow. Please check your work and make sure that you understand how to evaluate a function. Okay, the next 4 problems all deal with domain and range, and I believe just one of them is graphical, or is going to be graphed and will be a visual problem. So if we take a look at this function here, in order to find its domain, we have to look from left to right. So the leftmost point that it almost hits is at negative 4, and then the rightmost point that it hits would be at 3. This is, again, the x direction for domain. Domain is x. So the leftmost point is negative 4, and the rightmost point is 3. Again, looking left to right. Now, we can't hit negative 4, it's open, but we can hit 3, it's closed. So that's why we have the open parentheses and the closed brackets. The range is the same idea, except we want to look down to up. It's the y direction for range. The lowest y value that we take on, well, almost, is negative 2. And the tallest, the highest one, is 5. So we're going to go from negative 2 up to 5. And again, we're not quite hitting negative 2. It's open, but we are hitting 5. It's closed. The next 3 problems deal with finding the domain and range, just domain. So just domain, algebraically from a function. And so we want to realize that, okay, the domain is going to be restricted when there's x in the denominator. and or when there is x under a square root. This is because the denominator cannot be 0. So if we have x in a denominator like we do here, we want to set our denominator to 0. Now setting this to 0 looks a lot like the factoring we did earlier. So that's just actually what I'm going to do. I'm just going to factor the denominator and then figure out what makes it 0 so I can exclude those values from the domain because they don't work. In our denominator, the two numbers that multiply to -14 that add to -5 are a -7 and a +2. And so that's how our denominator factors. Then we have x minus 7 in the numerator, which you can also put in parentheses if you'd like. So the two values that make our denominator 0 are 7 and -2. So x can't be -2 or 7 because it makes the denominator 0. Yes, these cancel, but that doesn't matter. That just means there's a hole in our graph at 7 and there's a vertical asymptote at -2. It can't be either value that makes the denominator 0. Therefore, we have to exclude these two values from our domain. We have to exclude them from the domain. So our domain is every single thing except -2 and 7. So I'm going to erase the range here, and we'll do the domain like this. So we can go all the way from -infinity, but we have an issue at -2. We cannot equal -2, so we're going to get really close to it, but have the open parentheses. Then union, we skipped over -2, and then we went all the way up to 7, but we can't be 7. But then we skip over 7, and we can go all the way back to infinity. So because we had two issues in our domain, two numbers that x can't be, we're going to have 3 intervals here because we have to jump over -2 and we have to jump over 7. All right, go ahead and try g of x. I want you to find the domain and write it in interval notation just like we did for this example. Go ahead and pause, try it, and then play to check your work. Our solution is these 3 intervals down here. The last one I'm going to take a look at is f of x, a different f of x, and we want to find the domain. The other issue with domains, besides x being in the denominator like we did before, the other issue is when x is under the square root, because we cannot have negative values under the square root. So x plus 3 has to be either 0 or greater than 0, 0 or a positive number in order to work. So what we're going to do is we're going to set what's under the square root, called the discriminant. We're going to force that to work. Force it to be a positive number or 0. And then when we solve, we'll see that that's the case when x is greater than or equal to -3. Try plugging in numbers that are greater than or equal to -3, and they will always give you 0 or greater under here, which is good. If you plug in numbers that aren't in this interval, they give you a negative under the square root. To write this in interval notation, we can start at -3, we can equal -3, and then we can be greater than it, which is all the way to infinity. All right, the last topic will be graph transformations, and these involve a multiplier out front, changing the y value, shifting left or right, which means a plus or minus next to the x, flipping or reflecting over the x or y axis, and shifting up or down. So let's just do a couple examples here. I think examples are the best way to learn this, and that can help. So our original is g of x, right here. And then we want to transform g by doing two things. The first thing that we're going to do is this vertical stretch here. So because it's out front, it affects the y. So this is like a vertical stretch. And what it's going to do is it's going to affect the output, or the y value, by a factor of 2. Then, on the inside here, this plus 3, I just meant to underline the plus 3, this is a horizontal shift. It's horizontal because it's next to the x, and horizontal shifts are always opposite, so since it's plus 3, we're actually going to move left 3. We are going to do the horizontal shift first and then the vertical stretch second. The order that you do these, it does matter, but I don't think any of the ones on your test, the order will matter in the end, but you do want to focus with going left or right first, doing any vertical stretches second, then do any reflections third, and lastly we shift up or down. So the first thing we're going to look at is the horizontal shift. So we're going to be going left 3 from all of our points, because that plus 3 means we're actually moving to the left 3. So this point, we're going to go left 3, same with these other two. So the first point will go left 3, the next point will go left 3, and then the final point will go left 3. And then our very final thing that we're going to do, because this is not completely done yet, I'll do the vertical stretch in yellow, and that'll actually be our final. So now what I'm going to do is multiply, since there's a 2 out front, I'm going to multiply all of our y values by 2. So this y value here is at 3, so it's actually going to be shifted, well, multiplied up to 6. And then this y value here is 0, so times 2 keeps it at 0. Then lastly, this y value is at 1, so the vertical stretch moves it up to 2. So our final graph is actually going to be in yellow here. There we go. Whoops. Well, that got a little messed up there, but that's okay. So we took g of x, the original function, and then we saw that there was a horizontal shift, which we do first, and then a vertical stretch, which we do second. All right, this next example, we're going to do the same thing. We have g of x, our original parabola, and then we want to transform it to get negative g of x minus 2 and then plus 1. So as we said in the previous example, we want to do the horizontal shifting first. Since it's x minus 2 in there, that means we're actually going to move to the right 2. The second thing we're going to do is a reflection. The reflections are negative signs, so either out in front or in front of the x. So when it's out in front, we reflect over the x-axis. And then finally, this outside the parentheses shift is the last thing we do. It's the vertical shift. So this is up 1 since it's plus 1. All right, so the first thing we're going to do is go to the right 2. So all of our coordinate points, I'm going to move them to the right 2 units. There we go. And then, so I just did this part here, g of x minus 2. The second thing we're going to do is take that yellow parabola and we're going to reflect it over the x-axis. And I'm actually not going to be able to do that in white, obviously. So I'm going to do that I'll make it black. So I'm going to reflect it over, that stays there. This is 4 units above the x-axis, so it's going to end up 4 units below. And, oops, same with the other point. And lastly, we want to move it up 1. So we're going to take the black parabola and move all the coordinate points up 1 from where they are. Now that one's pretty simple. That one is just an x squared. So if you plug into your calculator that this is x squared, you can actually plug in and double check your work. So what that would look like is there's a negative out front, x and then minus 2 quantity squared, and then a plus 1. Because we took our original function, had the negative out front, and then we had an x minus 2 in place of x, still squared, and then the plus 1 at the end outside of the parentheses. So if you can recognize it, you can check on your calculator as well. All right, thank you for bearing with me on that long review, but I hope it was helpful and it follows your test almost exactly. I hit what 19 or 18 of the 20 questions look like. So those are all the topics that will be covered. It will be on Alex. It'll be open from September 24th at 12:01 a.m. through Friday, September 25th, all the way until 11:59 p.m. You should start it at least an hour and 30 minutes before it closes, though. You will have 1 hour and 30 minutes to take it, and it will be on a lockdown browser. However, you still have all of your notes that you've taken, your practice problems, everything like that. So make sure you have everything ready, you're in a quiet space before you sit down to take your test, and best of luck. Bye-bye.